When you are taking a sample size of n equals 5, what is the shape of distribution of means histogram when your parent population is right skewed? So because it's a small sample size and it's right skewed, it's going to stay right skewed.
When you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is right skewed? Since it's a large population sample size, it's going to be normal skewed.
Hold on, I opened the wrong quiz, so I'm opening up a different quiz right now.
Okay.
You can go to the
when
next
you are
one.
taking, yeah, I'll do it. You can grab the next one. When you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is normally distributed? Since the parent population is normally distributed and it's a small sample size, it'll still be normal.
Again,
which question was that? That was 5, right?
That was 5, yeah.
Okay. Do you want to do 6, Garrett?
Yes. It says when you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when parent population is normally distributed? It's normal, right?
Yep.
Okay, number 7, choose all the correct responses. When would the distribution of means be normally distributed? Data are drawn from the population that is normally distributed from a sample size. So that would be one of the reasons. Data drawn from the population is normally distributed and the sample size is large. That would be one of them. Data drawn from the population that is right skewed and the sample size is small.
That would not be one.
Yeah. And then data drawn from the population that is right skewed and the sample size is large. That would be one of them too.
Which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, the sample mean will follow a normal distribution. No. For bell-shaped data, approximately 68%. No. If the sample size is large, the sample mean X will be close to the population mean mu. Yes.
Yep.
Well, oh, wait, did you say the third one?
Yeah.
So that's what I thought too, but it's the fourth one.
Oh, no. I did this in the
homework quiz.
Practice stuff too, yeah. It's the sample size is large. The shape of the distribution of sample means will be approximately normal. Yeah, those ones are just so close.
They're so close, yeah.
Yeah.
They're super confusing. I had a tough time.
Yeah.
All right. So let X be random variable with population mean U equals 10 and population standard deviation sigma equals 0. Close the sample mean. Suppose the sample mean size n 36 is drawn from this population. What is the mean of the distribution of sample means? Let's see here.
It's going to be
equal 10. To the population mean.
Yeah, what formula do we use here then?
No, so it's just equal, so the population mean and the distribution of sample means are 1.
Hold on, tell me what?
The population mean and sample mean are going to be the same. They're both 10. The sample size is 36 and it is, so that means it's going to be normally distributed. There's not going to be anything.
Okay.
They're going to be the same.
Awesome. What is the standard deviation of this distribution of sample means? And so that's 1. As you take 10 over 6 divided by rad 6, which is
right, because we do the population mean
divided by
the standard deviation, and then that divided by the square root of n N, right?
The sample size, yeah.
Is this me next?
I don't know.
You can go. I'm just making sure that I have the formula in my head all down. So
I do not have the formula in mind, so good for you guys. Regardless of the distribution of the population, if the sample size is large or greater than 30, what would be the shape distribution of the sample mean? It would be a normal. If the sample size is large enough, isn't the distribution normal?
Yep. And I could do 12 too. What theorem would justify your response to the last question? So if we have a large sample size and a normal distribution, that's the central limit theorem.
all right, hold on. I got stuck behind.
With I had the wrong quiz open. So with question 3, we put down normal.
Yeah, no, it's skewed right because it's a small population and it's already skewed right.
Okay.
Sorry, for question 12, you said central limit theorem, right?
Yeah, because I put the law of large numbers on the first time.
Yeah, they're so close. So close. Okay. Sweet. Got an A on that.